Okay, hello everyone. So we want to talk today about end-to-end encryption to the pod. So when we set up our system, we had some challenges to do this. But yeah, let's first start with introducing us. So we are Loodse. We are a startup from Hamburg, and I'm Sebastian, the co-founder and CTO. And yeah.
I'm Jason. I'm the senior infrastructure architect at Loodse. So the big thing that we do at Loodse, which is kind of cool and very exciting, is Kubernetes. So Kubernetes Container Engine. We're kind of like Google Container Engine for everybody who doesn't use Google. So GKE provides you with a great user experience. It makes it really easy for you to stand up Kubernetes clusters and makes it very, very simple for you to do upgrades and all of those kinds of things. But not everybody can use Google, especially here in Germany where you have things like data privacy laws and can't necessarily export your data to a US provider. So you're kind of restricted on the hosting providers that you can utilize, and that gives us some issues. So we provided Kubernetes, which basically gives you the GKE experience on several other cloud providers, specifically AWS and DigitalOcean, as well as on your own hardware or anybody that supports Ubuntu 16.4 or greater.
So yeah, and when we start building Kubernetes, we get inspiration like how Google is running it. What we are doing is running each master cluster in an own namespace with all the components like an API server and controller, scheduler, and etcd. But here is the main challenge about networking and traffic. And this is where we want to talk today. So how we get traffic into the cluster and how we solve this with K8SNIff. So on our side, we have Kubernetes running where we have our own API server, an own controller to really control what we like. Now it's more called operator, a Kubernetes operator. Then for all the web traffic, we use Nginx. But we still had some, we need like encrypted traffic to the pod. And when we started, it was not really possible. We couldn't use like ingress, we couldn't use Nginx because we want to dynamically configure it. And we first tried to do it with Nginx, but it was every time quite hacky to do this. And so we were thinking, okay, is there a better way to do this? And how can we solve this in a better way? And yeah.
Yeah, so the big issue that we had was especially around etcd. So etcd, we previously had 2 etcd instances. We weren't using CNI as of yet. CNI was still kind of new when we first deployed this. And so to configure Flannel for the nodes, we had to have a public etcd. And we didn't really feel comfortable with just terminating TLS certs right at the Nginx controller. That required a lot of configuration on our side. And so we tried to figure out a better way, and that's where we came up with K8SNIff. So we wanted to be able to get traffic straight from wherever the source is right to the pod and allow the pod to handle the TLS offloading, and to do that in a transparent way where we could still leverage the power of the ingress resources that are available in Kubernetes. So we've covered some of the problems. We really want to maximize that utilization of TLS. And it's not just for etcd. You can use that for the API server. You can use it in a lot of other use cases, which we'll go into a little bit later. But it's a challenge that hasn't been addressed as of yet in the Kubernetes ecosystem. So we went, okay, well, we've got some time. Let's do something fun. So we have ingress right now. And this is what we wanted to see. We wanted to be able to take the TLS and the encrypted traffic, feed it a host name, have that feed through the ingress right into the service, right to the pod, and have the pods take care of that TLS offloading. The problem is with all of the existing ingress controllers that were available, whether that be the GKE ingress controller, the Nginx ingress controller, or a couple of the other implementations that came out earlier, that was what it actually looked like. You did your TLS offloading at the ingress controller, and if you didn't do that, well, stuff broke.
Yeah, and In the future, we will use this for the API server of Kubernetes. So when we started building this up, we use this for etcd, especially to secure communicate to etcd. We use client certificates, and with client certificates, it's not possible to do the TLS termination on the ingress. So it really must go to the pod that you can authenticate with the client certificate on the pod and can ensure, okay, I'm a valid connection, and you cannot terminate and re-encrypt the traffic. So you really must push the traffic to the pod, and this was not possible.
So this was our goal, TLS to the pods, and this is how we solved it, was with K8SNIff. So it does layer 3 forwarding of the traffic into the service. But what we do is we look at the hello headers, the TLS hello headers that are coming in from the SNI stuff. And so we can take a look at that, figure out where we're supposed to be directing that traffic using the ingress resources that are available in Kubernetes. So for you using K8SNIff, all you have to do is treat it just like any other ingress controller, except for knowing that instead of it doing the TLS offloading, all it will do is take that and shove it right to your pod. So you don't have to worry about anything, you don't have to do any magic, you don't have to do any configuration beyond your simple deployment to tell K8SNIff to exist in your cluster and use the ingress resources that are already available. So semantically, we tried to be as adherent to all of the other ingress controllers that were available in the ecosystem, but provide a little bit of a different layer of where we pass the traffic through. So this is what it actually looks like. So you have a client. The client will pass TLS traffic. It'll hit K8SNIff. K8SNIff will read these SNI headers. It will pass it through to the service. The service passes it through to the pods. Same kind of stuff that you guys are very used to using other ingress controllers in the system. We could theoretically have used, like a load balancer. The problem is that we aren't always on a cloud provider that will provide us with a load balancer. And then we start going into the magic port number issue, where we just have to figure out, okay, what ports are already allocated, start using a node port that we can dynamically assign. And we didn't really like that semantic. It makes it really hard to start figuring out how to deal with stuff. And that puts pain not only on the cluster operators, pain on the cluster, but it also puts pain on the users as well. And we really, really didn't want that, because we wanted things to be as simple as possible for everybody to be able to use.
Yeah, and the only thing what you mainly must add is on your pod, you must ensure that you have certificates there, and then everything is more or less transparent. You deploy your ingress, K8SNIff will read all your ingresses and then forwards it to the services, and it going forward to the pod. So no really much to do extra, only deploy certificates with your deployment or with your pods.
Yeah. So and this works really well for native applications that want to use certificates on their own in the application. So if you have applications that really, really don't like having the TLS offloaded somewhere else, there's a couple of things in like the Atlassian stack where they really want to hold those certs. And so if you want to utilize those things, but you don't have something like K8SNIff available, you start running into problems really quickly, and you have to start doing some magic, pushing things around to different port numbers, and that's just not fun. So this really allows you to kind of leverage the power of SNI and leverage the power of ingress without having to deal with doing that TLS offloading at the point of ingress. So we'll do a quick demo here, and we'll go through a couple of the configuration files to kind of show you guys what we're looking at. So I'm totally cheating, by the way. I'm a copy-paste ninja. So the first thing we'll do is we'll go ahead and just deploy the initial stuff. So, oh, wrong one. So just to be fair, I've done some contrib work on the Nginx ingress controller, so I'm not bashing on those guys at all. They do a great job, and it's an awesome ingress controller if you're doing layer 7 stuff. So just so that it's very clear that we're not trying to say, use this instead of Nginx or something else. All I'm trying to say is if you have these kind of problems, definitely leverage that. If you can work at the layer 7 level, definitely use that, because it is way, ingress is awesome, right?
And why we built a separate tool is like, because when you look at the coding, it's really a small Go binary, and it doesn't do much. It's only really looking at the ingress, listen on the ingress resources and configuring itself and then forwarding it. And we were first thinking, okay, should we enhance some of the existing tools? But we were thinking, okay, for this small problem, let's create a separate ingress, because you must run a big Nginx when you want to forward it only the traffic to your pods.
Yeah, for sure. So all I've done here is I've just pushed in an Nginx ingress controller. So we'll go ahead and use that in an insecure manner with etcd, because that's just an easy way to do this. So magically, we have etcd in our cluster up and running. It should theoretically have some data in there if I haven't completely broken my demo. So, the internet has been shaky today. All right, so there we go. We just went through the Nginx ingress controller, port 80. It did its stuff and passed that along. So now, great fun. We're very excited. But let's go ahead. I'm going to jump over. And let's see what this looks like if we go ahead and start using etcd with its certs. So all we're actually doing here, if I can find the deployment, is we're just setting up here the client cert auth, giving it the certs and saying, hey, validate this stuff. We're going to do TLS in both directions. Fabulous. Problems start happening here. So we'll go ahead and hit this on port 80. Oh, wrong window again. On port 80, obviously that's going to fail. It's going to freak out, right? So let's actually hit it on 443, where Nginx is serving its TLS stuff. Well, it's going to have a problem too, because the right resources aren't available. And the right resources can't be available at this level, because we're doing the TLS offloading, or we're telling etcd to do the TLS offloading and to validate those client certs. But we can't actually pass any of that through, because Nginx insists on doing the TLS offloading at this point. So this is where K8SNIff comes into play, and we can actually leverage that. So go ahead and push K8SNIff into the cluster. And while we're doing that, I'll just show you guys what K8SNIff kind of looks like. So we're pushing it into its own namespace. It has a service that we aren't actually leveraging, because we're just using host network. And this is what the deployment looks like. So we're just pushing one of them in, and we run this fabulous little binary with a JSON configuration file, and this is what that JSON configuration file looks like. Bind everything, serve on 8443, talk to Kubernetes. And if you need to put in a, provide a special Kubernetes config, it just takes the standard Kubernetes kubeconfig format. You can mash that in and away you go. So very, very simple, very easy to operate. There's not really any magic going on here except for the host network stuff, just because I'm not using a service on a cloud provider, just using a node on DigitalOcean. So we've gone ahead and deployed K8SNIff, and I do need to apply this again. We're going to, theoretically, there's potentially a bug in 1.6 that I found this morning, so we might have some problems, but we'll see if this actually works. So let's go ahead and we'll actually go and hit, we're serving on 8443 with K8SNIff. So we're just going to just change the port and do the same hit that we were doing before, and we get a connection refused. Oh, that's fun. Oh, thank you. Somebody is paying attention. I appreciate that. Oh yeah, there's no K8SNIff running in the cluster. That's kind of a problem. All right. So now that we have K8SNIff running in the cluster, theoretically, magically, stuff will work. Oh, there we go. So now we're talking to etcd. We're doing client auth using the certs. It's talking back to us, again, using TLS. We're doing all of the certificate verification. Everything is actually being passed through on layer 3, and we don't have to worry about the layer 7 complexities of like trying to do all of the offloading and drop it back down. Everything just magically happens right at layer 3. We push that traffic forward, and away you go. So it makes it really, really easy. We also leverage this for the API server has a couple of calls. I can think off the top of my head. I think it's any of the streaming stuff. So kubectl exec, kubectl logs, and port forward, I believe, and potentially proxy. I don't remember if proxy uses that or not. But you actually have to use a layer 3 traffic for that. So if you're putting your API server behind an ingress controller, like Nginx, that's working at layer 7, you immediately break all of those functions. For us, where we're running, if you're running just one, you can bind those ports and be happy with that. But where we're running multiple clusters, theoretically on the same nodes, we don't always have a load balancer available. For us, it's very important for us to let you utilize those functions because when shit breaks, you want to have the logs. You want to be able to get into your pods and actually do stuff within them to kind of see what's going on, debug them, throw them away, and get new ones, right? So what we do is we also leverage some other ports. We do all of the REST-based forwarding for the API server using the Nginx ingress controller currently. Do we? I think we switched that actually last week. So now everything's actually running for the API server through K8SNIff. But it used to be that the REST stuff would go through one port, and then you could tell the API server to tell its clients to do the functions that required streams on another port, and those were all going through K8SNIff. I think now everything is just going straight through K8SNIff. And so you just have a well-known port that everything kind of happens on, and you don't have to worry about it anymore. So that is the demo. So let's talk about some of the other potential use cases.
Yeah. We mainly use it for HTTPS traffic, but there are definitely a lot of other use cases. So in general, it should be possible to use K8SNIff for every TCP traffic where an SNI header is set, because it only looks into the TCP header and checks if there's an SNI header, checks for the domain and forwards it to the specific service. So theoretically, we didn't try all this. So, it's open to you. We would like to get feedback. But if you want to run POP server, SMTP server, or some other things on a Kubernetes cluster and want to secure this on the pod level, it should be possible with K8SNIff to really forward the traffic to the pod. And after we started this, we used this for our own infrastructure. 1 month later, we had the same problem at our customer. So they run own certificates for some test environments. They said, okay, now we need it on the pod level, the certificates. And so we said, okay, yeah, we have something. Let's try K8SNIff for this and forward the traffic to the pod. And yeah, test it out. It's on GitHub. It's on...
yeah, so... To find it on GitHub, oh right, I closed Chrome for very good reasons. I didn't want to get notifications while we were having this chat. So you can find us at GitHub/Kubernetes. K8SNIff is there. You totally can't see any of this apparently. That's awesome. Oh, I totally could have left notifications open. Would have figured out if I got Tinder matches. Yeah. All right, so you can find the project here. So it's github.com/kubernetes/K8SNIff. Yeah, it's really simple. We've got some example ingress, some example configurations. I'll mash an example folder in there with some deployments probably later on today. And yeah, if you guys have a need for this, please take a look at it. If you run into any issues, let us know. Hop on our Slack or just open an issue, and we're happy to work with you on it. If you guys have any pull requests for maybe using it in another use case that might have some special considerations, we're totally open to those and happy to hear how you guys want to use that. But it's just the big thing about it is it's just another tool in your toolbox. So, please happily come, use it, contribute. We'd love to have you guys around. And if you have questions, hit us up.
And I mean, it's a good point how easy it is to extend Kubernetes with your own requirements. So when you're looking at the coding, it's only a few lines where we do things. So reading the ingress. So it's really a really good example. When you have specific requirements and Kubernetes or the current setup doesn't support this, you can build up your own tool based on Kubernetes and integrate this and run this. And you are free to use it.
Yeah. Like I said, you can find us on our Slack. So we've got a Slack in at slack.kubermatic.io. You can also find me pretty much everywhere at K8SNIff. And you're Scheele?
Yeah.
Okay. So you can find him through me because his name is hard to spell. I still don't get it right. So do you guys have any questions at all? All right. We'll start from the front and work our way back, because that's how I arbitrarily decided to do it. So you, sir.
Cool. So can you give an advantage of using K8SNIff rather than decrypt and re-encrypt, when you don't care about client or whether...
Yeah. So the question for those of you in the back was, is there an advantage of using K8SNIff over something else that will do the TLS offloading and then re-encrypt and send it to the pods? So one of the big ones is client auth, like you mentioned. The other one is speed. So this is a little tiny Golang binary, and it just shoves traffic through, it opens up some pipes. So it makes it much, much faster, and you don't have that overhead of doing the TLS offloading, all of the checks, then re-encrypting and pushing it through to the pod. So it can definitely help you if you have latency issues with, it really depends on your traffic loads. But if you have to decrypt everything and then re-encrypt it and pass it through, you're incurring a lot of latency, you're incurring theoretically a lot of CPU load. So it avoids doing all of those things by just passing it right through and letting the client handle it.
And the other thing is security. With this, you can really ensure that you have an end-to-end encryption without some man in the middle who doing some stuff. So it's really also when you need secure communication between your client and your pod or your container, there is no way to do this or to do this on the ingress level.
You, sir, had a question. So to do the routing, we leverage the services. So all we have is am I still on the right thing? Awesome. So all we do literally is use, sorry? Well, we don't do any path stuff. So this is all layer 3.
So it's host-based. It's based on, it's based on this entry. So we are looking into the ingress, in the TCP header for the SNI entry, and then you find this header, and then we route it based on to the service, and the service connects it to the pod. So you can even make one hop less, that you automatically, instead of moving it to the service, reading the pods which are under the service to get rid of one more hop. But currently we say, okay, service is enough, so we forward it to the service, and the service forwards it to the specific pod.
And as you can see in this ingress spec, there is no path defined because we can't see what's going on in the traffic. We don't do any path-based routing at all because it's all done at the layer 3 level. Paths are irrelevant. That's all at layer 7. So, do we have other questions? Nothing? Oh, Henning.
So do you consider combining it with another ingress controller?
Yeah, so what we usually do, so because we have like a UI and an API and stuff that are running in our clusters, we run K8SNIff to handle this specific traffic, and we also use the Nginx ingress controller to handle any of our layer 7 traffic. So this isn't to replace anything else. We use this to, yeah, so the big thing that kind of is awesome about Kubernetes is we've got this fabulous little ingress class. So that tells the ingress controllers, and as far as I know at least, they all respect this. So even if you're running on GKE, which comes with the embedded GKE controller, you can run the Nginx ingress controller and bind certain things to the Nginx ingress controller if you want to do things like client cert authentication, but terminate that at the Nginx ingress controller. It allows you to do all of that stuff. This is, like I said, just another tool in the toolbox that allows you to kind of leverage a little bit of a different semantic around how traffic is routed, but still use the exact same resources in Kubernetes and not have to really care about what's happening underneath. Any other questions? Awesome. Let's go get some coffee, huh?
Yeah. Thanks.